This is AQA A-level Chemistry. It is a required practical question and it's based on RPA3. Going to recommend you pause, have a go on paper and then review. You will need graph paper for this question if you're going to try it. So here are parts A, B and C. Here are parts D, E and F. And now you've had a chance to try, let's take a look at the answers. So, student investigating the effect of temperature on rate of reaction between sodium thiosulfate and hydrochloric acid. The student mixes solutions together in a flask, places the flask on a piece of paper marked with a cross. The student records the time for the cross to disappear, and the cross disappears because the mixture becomes cloudy. We've got a table of students' results that we can see that is not yet fully filled in. For A, the student uses a stopwatch to measure time. The stopwatch shows each time to the nearest 0.01 seconds. Why would a student record time to the nearest second and not the nearest 0.01? Well, this is really about the fact that it's difficult to judge whether you can accurately say that the cross has disappeared within 0.01 seconds. Doing it as individual seconds, that's certainly more manageable. On to B, the rate of reaction is proportional to 1 over T. So you need to complete the table above. We've got one gap here. We've got a T of 12. So we want 1 over T, which is 1 over 12, which is 0.083. So I'm putting that figure in here. The marks on the graph are for correctly plotting and drawing a line of best fit. So let's start working through. We've got our temperature of 54 at 0.083 that we can see here. 49 at 0.0227. We've got 42 at 0.0385. 36 at 0.0278. 31 at 0.0208 and 22 at 0.0115. Now what you can definitely see here is an anomaly, something that really stands out. There is quite a defined curve, but there is the anomalous point here at 49 degrees Celsius. So we're not going to include that in our line of best fit. So we can now draw our relatively smooth curve. I'm going to transfer that graph over so we can answer parts D, E and F. For part D, use your line of best fit to estimate the time for the cross to disappear at 40 degrees Celsius. Show your working. So show your working means draw the lines on. We're going to draw a line up from 40. You can see where it reaches the line of best fit. And the correct answer will be based on where you've drawn your line of best fit. So for mine, I'm going to read across and that comes to 0.036. Now that's 1 over T. I don't want 1 over T, I want time. So 1 over 1 over T, 1 over 0.036, gives me a value of 27.78 seconds. Moving on to E, suggest by considering the product of this reaction why small amounts of reactants are used in this experiment. Well, let's take a look at the actual equation to see if that helps us. And is there anything about what we're making that we wouldn't want to make much of? It's actually the SO2. SO2 is a toxic gas, so keeping the volumes produced of that low is definitely a positive thing. And finally, moving on to part F, the student could do the experiment at lower temperatures using an ice bath. Why do you think the student chose not to carry out experiments at temperatures in the range 1 to 10 degrees Celsius? And it really is as simple as the fact that at those low temperatures, the reaction would be very slow. It would be too slow. You would not be able to actually get to a point where the cross disappeared. That takes us to the end of this question. Thank you for listening and goodbye.